In this question, we're shown a circle with radius 1 that touches the side of a rhombus. Each of the smaller angles between the sides of the rhombus is 60 degrees. We're asked to find the area of the rhombus. Before we proceed with calculations, let's fill in the gaps of the things we know and place them onto the diagram. Because of the symmetry, we know that the angle in the top right corner will also be 60 degrees. We also know that the angle here and here will also be equivalent. As a rhombus is a quadrilateral, we know that the sum of all the angles in a quadrilateral will equal 360 degrees. 360 subtracted by 120, that 120 is found by the 60 degrees times 2 we've already labelled, gives us 240 degrees left to spare. This divided by 2, as the angle is shared equally, is 120 degrees. So let's add this on as well. We're also told the radius is 1, so let's add this in. The two lines that have just been drawn on, therefore, both have a length of 2, as if the radius is 1, the entire diameter would be double that, or 2. These lines are an example of a tangent of a circle as they touch the rhombus. These are a straight line that touches the circumference of the circle at only one point, and the angle between the tangent and radius is 90 degrees. So as you can see here, I've added in the 90 degrees to the tangent of the circle. It should also be noted that as a result of the symmetry, these two sides, these two areas, have the same area. And these two areas also have the same area. This idea will be utilized later. Using all this information, we can now break up this first area into a right-angled triangle. As we're bisecting the large angle, this new angle is half of it, which is 30 degrees. We also know that the radius is equal to 1, so this side is equal to 1. We can then use trigonometry to find the length of the adjacent side, this side here. If one side is the opposite and the other side is the adjacent, this must mean we use the tan rule. Tan of 30 is equal to root 3 over 3. And using our trigonometry triangle, in order to find the adjacent, we divide the opposite side, which is 1, by tan of 30, our angle. This would give us 3 over root 3, so therefore the adjacent equals 3 over root 3. This is written out here. Now in order to find the area of a right-angled triangle, we multiply the adjacent side by the opposite side and then divide this by 2. But remember, as a result of our symmetry, we have 4 of these equivalent right-angled triangles. So therefore, 1 multiplied by 3 over square root of 3 divided by 2 and then multiplied by 4 will give us the area of all these 4 triangles. Working this out gives us 6 over the square root of 3. So therefore, this area here, which we're going to call area A, is equal to 6 over the square root of 3. Now let's work out area B. Finding out the area of area B involves a very similar task as before. Using this angle here and dividing it by 2, we can work out that this angle here is equal to 60 degrees, and that the length over here, which is the radius of the circle, would be equal to 1. And remembering that this is a right-angled triangle, we can calculate using the same trigonometry rules the area of this triangle. Once again, as this length here is the opposite side, we're working out the adjacent side, which is this length here. We're using the same tan rule. Remember that in order to find the adjacent, we divide the opposite side by the tan of the angle. Tan of 60 is equal to the square root of 3. 1, which is the value of the opposite, divided by the square root of 3, can be simplified as the square root of 3 divided by 3. This would be the value of the adjacent. Now, in order to find the area of area B, we multiply the value of the adjacent by the opposite, then divide this by 2, working out the area of the right angled triangle, and then we multiply this by 4. So the value of this right angled triangle would equal the square root of 3 divided by 3, and then halved. And that gives us the square root of 3 over 6. But now, as there are 4 of these triangles, we then multiply that value by 4. This gives us the final value of area B as 2 square root 3 divided by 3, as we can see here. And the final step for this question is to add the two values together of area A and area B. So therefore, the final answer for this question would be 8 square root of 3 over 3, which is found by adding areas A and areas B. This can be seen in the answer here.